Hello everyone! We are really excited to be launching our new energy aggregation and energy services cloud-based platform called Watts Battery Link. Watts Battery Link offers visibility and control to the grid edge while providing vital behind-the-meter information to help utilities and entities alike plan their networks more effectively and save millions in grid infrastructure upgrades. Our platform enables access to real-time control of all connected Watts battery modules to offer opportunities for rapid demand response and energy services such as peak shaving, frequency regulation, and many more in just seconds. Once you enter the platform, you will be prompted to the landing page, which includes the map with all the houses equipped with Watts battery modules. In this particular case, we are looking in California, and if we zoom in, we'll be able to see the exact location of the households equipped with Watts battery modules. Below the map, we have the filtering panel. This panel allows the user to filter out specific locations where they might be facing power outage, voltage issues, or maybe their system is having some errors. Below the filtering panel, we are able to see the snapshot panels of the system state. Here we can see in the first panel the capacity of our energy storage devices and the available amount of energy already stored. Next to that, I can see the power available of the installed capacity of our energy storage devices. And next to that, we can see the amount of solar power that is available at the corresponding time in the network. Below that, we have the real-time statistics that allows us to see how much energy is provided by the grid and how much is provided by the solar or Watts battery modules. So in a sense, it allows us to see the composition of the energy sources for the load consumption we have in the network. Also in this panel, we provide a very vital information for the state of the grid, which is the voltage, maximum and minimum levels, as well as the average value of the voltage profile within the network. If we scroll a bit down, we'll be able to see the consumption statistics. This allows us to see the real-time and time series behavior of the load consumption, and the user is able to visualize the exact value of the consumption for each time of the day of their interest. Now, if they want to see more information, they can see also the real-time time series profile of the grid power. They can click on this here, and they can immediately see the information of the grid power values. In this particular case, because we are looking on a demonstration that assumes that all load consumption is provided by the grid, we can see that the two profiles are overlapping each other. Here we can enable the battery profile, which in this particular case is 0 because it's not providing any power. We have the solar, which is again also 0 because we are not generating any solar. And also here we have the battery capacity, which allows you to see the amount of energy already stored in the battery. So at each moment of the time, we can hover the mouse and we can get this information. If we scroll a bit further down, we can see the time series behavior of the voltage profiles in the network. We provide the minimum, maximum, and the average profiles. That is good enough to understand what is the state of the network at each time of the day of the corresponding network. Now the user, if they want to export this information, they have the option to do. So they can click on the export button and they will be able to download the file, CSV file that includes all this information and which is in a format that is able to be imported in any tool of their desire. Scrolling a bit further down, we can see the demand response section. In this section, the user can see the forecasted grid power in the network for the next 24 hours. And based on this, they can schedule specific demand response functionalities. For example, in this particular scenario that we're having here, we have availability for the peak shaving, which is a function that allows you to put a specific power limit on the grid. And in other words, any power that goes above this limit, it should be shaved. And how we do that? We essentially start discharging our modules the moment that the power goes above that limit. So we provide that energy locally, so we don't need the grid to supply that energy anymore. Next to that, we have the regulation down service, which this service is usually requested in cases where the frequency is increasing. So there is a request for generations and generators to reduce their power. Or in other words, what we can actually do, we can increase the demand, which essentially is the same behavior as reducing the generation. And in this particular case, what do we actually do in order to increase the demand? We are switching the behavior of VATS battery modules into charging mode, which will essentially increase the load conditions in the network. On this section here, we have the regulation up. In this particular case, the service is requested in cases where the frequency is dropping, and we need essentially to increase the generation, or we need to reduce the demand. In this particular case, in order to reduce the demand, what do we actually do? We start discharging our modules to supply the local demand, and therefore no more energy needs to be provided by the grid.